Magis Day class, this is Miss Morales once again. And if you have watched my previous video discussions, I assume that by now you have mastered the skill of multiplying two or more monomials and even multiplying a monomial with a polynomial. If in case you still need to review and watch it again, kindly check the suggested videos on top of this presentation. Alright, so for today, you will learn to multiply binomials. Going back, a binomial is a type of a polynomial which consists of two terms. Alright, to multiply a binomial by a binomial, you have to apply the distributive property more than once. Now let's have here an example. The quantity of x plus 3 times the quantity of x plus 2 is equal to x times the quantity of x plus 2 plus 3 times the quantity of x plus 2. Now notice that our first binomial is in red and our second binomial is in black. So basically here what we did is we distribute the terms from the first binomial to the second binomial. So we have x times x plus 2 plus 3 times x plus 2. Yeah, so that's the first time that we apply the distributive property. All right. Now, from here, we have to distribute again. Okay? You see those red no, terms in red? So we have to distribute them to the terms inside the parentheses beside them. So that will be x times x plus x times 2 is x times 2, and then 3 times x and 3 times 2. Alright? So that's the second time that we have to apply the distributive property. Okay, so again, we distribute the terms outside to the terms inside the parenthesis. So now we have here x times x plus x times 2 plus 3 times x plus 3 times 2. So from there, we have to multiply. Okay, so it will become x squared because x times x is x squared, and then x times 2 is 2x, 3 times x is 3x, and 3 times 2 is 6. Okay, and notice that we have here like terms. Okay, so remember what we mean by like terms. Like terms, these are terms that have common variables and uh, the equal exponents. No? They have the same exponents and the same variables. So we have here 2x and 3x. We have to combine them and simplify. So the simplified form will be x squared plus 5x plus 6. Okay, so this is the first method actually in this is the first method in multiplying a binomials. Okay, so we did the distributive property of multiplication over addition. Alright, so another method for multiplying binomials is the so-called FOIL method. Okay, so I'll still use the same factors. So we have here the quantity of x plus 3 times the quantity of x plus 2. So we begin by multiplying the first terms. Okay, so what's the first term in the quantity of x plus 3? Of course, it's x. How about in the quantity of x plus 2? It's also x. So we multiply these two first terms, x times x, and that will give us x squared. Second step is to multiply the outer terms. So what are the outer terms? If we're going to look at these two factors, we have x, and on the other end, we also have 2. So we multiply these two outer terms. So x times 2 is 2x. Right. Then we multiply the inner terms. Okay. So we try to identify what are the inner terms here. Okay, the inside terms. So we have 3 and x. There you go. So we multiply 3 times x and that will give us 3x. And the last thing is we have to multiply the last terms, of course. So when we say, if we have first terms for number 1, we also have to identify what are our last terms. Okay, so for the first binomial, the last term is 3. And for the second binomial, the last term is 2. Alright, so we multiply these two 3 times 2, and that will give us a product of 6. And from there, we have to write all the products together. X squared plus 2x plus 3x plus 6. Okay, x squared being the product of our two first terms, 2x the product of our two outer terms, 3x the product of our inner terms, and 6 the product of our last terms. Then, from there, if there's a need to combine like terms, given that we have 2x and 3x there, so we combine them and we simplify, right? So x squared plus 5x plus 6, that will be our final answer. Okay, now let's have another example. So we have here the quantity of s plus 4 times the quantity of s minus 2. And notice again that our first binomial is in red and our second binomial is in black. Okay, so first we have to distribute the terms from the terms of the first binomial to the to the second binomial. Okay, so we have there s times s minus 2, which is the second binomial, and the 4 from the first binomial to the s minus 2, which is again the second binomial. So this is the first time that we apply the distributive property. And from here, okay, so we distribute again. So we distribute the s outside the parenthesis to the terms inside the parenthesis. So that will give us s times s, all right, plus s times negative 2, okay, and then plus 4 times s and plus 4 times negative 2. Okay, so as you can see, we distributed not just once, not just twice, but many times. Okay, now after distributing for many times, we have to multiply, no? So we have here s times s, that's actually s squared. And then what about s times negative 2? Negative 2s. What about 4 times s? 4s. And what about 4 times negative 2? Negative 8. Okay? And again, if there's a need to, if you see that there are like terms, do not forget to combine like terms. Okay? So you have here, the final answer will be s squared plus 2s minus 8. Because negative 2s plus 4s, okay, so remember this one, you have to identify, no, negative and positive, so they're of different signs. So you have to do minus. What is 4 minus 2? 2. And which one has a greater value, the 2 or the 4? 4, of course. What's the sign of your 4s here? Positive, so you'll copy the sign. So you have s squared plus 2s minus 8. Okay, now another example. By the way, for the previous one, we applied the distributive property. We didn't apply FOIL method. Okay, now we have here x minus 4 squared. As you can see, um, Miss, where is the binomial there? The x minus 4, that's the first binomial. But notice that it is being squared. Okay, so this time, our base is x minus 4, and we have to multiply it to itself twice, since the exponent is 2. So it will look like x minus 4 times the quantity of x minus 4. Okay, and from there, we have to use the FOIL method. Remember, FOIL method is our alternative method. Okay, so if you think that you prefer doing the distributive property, then it's fine. Or if it's if FOIL method is way more convenient for you, then it's also fine. Okay, so again, FOIL method, we multiply the first terms first, and then the outer term and inner term and last terms. So x times x, these are our first terms. X times -4, our outer terms. And then -4 times x, our inner terms. And -4 times -4, our last terms. Okay, so we simplify them, we multiply. So we get x times x is x squared. X times -4 is -4x. -4 times x is -4x again. And -4 times -4 is 16. Okay. And then you combine like terms. So combine like terms. What are like terms there? -4x and -4x. And that will obviously give us -8x. Both are negative, so there's no need to subtract. So you just have to add. 4 plus 4 is 8. We copy the sign negative, so our final answer will be x squared minus 8x plus 16. So here's a helpful hint. In the expression x plus 5 squared, remember that the base is the x plus 5, the quantity of x plus 5, sorry. Okay, and if we're going to multiply it to itself, it will look like the quantity of x plus 5 times the quantity of x plus 5. Always remember that. Alright, so let's have here our last example. The quantity of 8m squared minus n times the quantity of m squared minus 3n. And again, in this case, we are going to apply FOIL method. But let me just remind you, whatever method you think is more convenient for you, then you can just go for it. Okay, so again, we multiply the two first terms of each binomial, and that's 8m squared times m squared. And then we also multiply the outer terms. So we have here 8m squared times -3n. And then we multiply also the inner terms. So we have -n times m squared. And the last terms, -n times -3n. Okay, so I hope that's easy for you to identify because they're of different colors. And from there, we multiply. Okay, so we multiply those in red first. So we have 8m to the power of 4. Now take note that for the red, for these terms in red, in multiplying them, we applied the product rule because they have a common base of m. Okay, so we add exponents, and that gives us 8m to the power of 4. And then we also have here 8m squared times -3n, positive times negative, class, that is -24m squared n. And then -n times m squared, that is -m squared times n. Take note that for these two, the blue and those terms in purple, we didn't apply any law of exponent because notice they don't have a common base. Okay, then we proceed with those terms in green. So -n times another -3n. So that's positive this time. Positive 3n squared. And again, we applied the product rule. So we have to combine like terms if there's a need to. Okay, and take note, we have here like terms, -24m squared n, and then the -m squared n. So they have common variables and equal exponents. So if we combine like terms, we will get 8m to the power of 4 minus 25m squared n plus 3n squared. Okay, so that